Awesome. Hey, everybody. Um, it's a pleasure to be here. First and foremost, I want to give a really big thank you to the volunteers and the organizers. This is my first DevOps, and this is probably the coolest conference I've ever been to. So, if a big hand. And since we're in France, bonjour. Always have to start out like that. My name is Cedric. I'm honored to be here from New York City. And as I said before, my first DevOps. Thank you for coming to a talk in English. I appreciate it. I would try to speak in French, mais mon français, c'est un peu nul, je sais. I've got a really fun and exciting session for you guys today because we're going to be tackling the issue of unstructured data and how to take your enterprise documents like PDFs, websites, other file formats, and be able to parse that and use that in applications like RAG, fine-tuning, agentic frameworks, and much more. This is a tools in action, so today we're going to be learning about an open source project that's called Docling, and Docling recently made it into the Linux Foundation as a project in the AI and Data Foundation. So you're going to be learning about an open source project, how to use it, and we're going to show a few different use cases of going through PDFs, going through different file formats, even going through images and being able to annotate those images, and all be able to use that in a RAG application. And I'll do that all here on my local machine, and let's see what happens with the demos. So we've got a lot to cover today. One thing that I learned recently is that almost 70 to 90% of all data that exists out there is unstructured data, right? So yes, you want to be able to use it in LLMs like open and closed source LLMs, but the thing is, it's very difficult to parse this data because of different file formats, different standardizations, and just this general sense of unstructured data. And unstructured data is everything that is not included in our traditional databases. So financial reports, PDFs, graphs, tables, all of these different file formats that LLMs aren't really used to working with as they primarily deal with Markdown and JSON. Now, there's solutions out there that you might have heard of from Google, Microsoft, Amazon, and all of the big players in the AI space in order to send your documents to them and they do the parsing for you. Maybe they give you back Markdown, maybe they give you back chunks and embed that into a vector database, but you're still sending your data and you're still paying for a service. So the idea is to be able to easily parse documents in addition to graphs and tables and all of this data that has traditionally been hard to use with an LLM and be able to use vision language models as we'll see today in addition to traditional OCR as many of us might have used before. So we're going to learn about this. We're going to learn about chunking, about extraction, parsing, and we're going to show this all in an application at the end of the day. But let's go ahead and get started. If you'd like to see the slides here, we've got this link on Google Drive so you can check out and check back on the information. And I'll have a slide for the repository that I'm using today as well. But we're going to learn about data preparation, parsing, and build a document pipeline to be able to do all of these different demos. So who's excited? Woo! Okay, so there's a need for advanced document parsing beyond what we've traditionally worked with because PDFs, technical documentation, meeting minutes, financial documents, knowledge base articles, all of this information is now more valuable than ever because we can use RAG, right? We can use LLMs to be a librarian and pull from hundreds of thousands of different documents and give you back the answer that you or your team might need. It's really helpful, right? The issue is, if we're going to be powering these RAG or fine-tuning applications, whether you're using a proprietary or open source model or running your models anywhere that you'd like to run them, you still have to deal with the issue of this unstructured data that can be hard to extract from traditional sources like PDFs and docx. So data is the key ingredient behind these AI applications. We're seeing that in the model training, right? Being able to produce these open source models, but also in the applications and being able to get the right answer back. There's a really funny example that happened recently. So I saw this online. It kind of blew up. It went viral because 20 scientific papers now feature the term vegetative electron microscopy, which doesn't exist. It doesn't exist at all. But what happened is that there was a source document that LLMs must have parsed that had vegetative electron microscopy on two different sides of the research paper, right? So someone extracted this data, and you started to see it in other research papers. Over 20 research papers all started to say, hey, there's this term that doesn't even exist at all, right? So this is really important because the way that we go through our data sources and extract them can have really significant implications on the results that we have, right? So it all matters about the context of the document we're working with. Because if we'd done this the right way, what it would have said is the spore develops in the vegetative cell, which then becomes a sporagum, and it doesn't have this weird kind of cutoff, right, that we then parsed with this open source project and received this Markdown source. So we want to try out parsing PDFs, for example, right? If you were to try a simple PDF parser or a web scraper or something like that, yes, you'll have fast results, but some of this might be noisy or incomplete data, and it's unfit for a lot of use cases. So one of the things I want to try out is by going to Devox, the actual website, and scraping this, right? So I want to be able to ask questions about the website, be able to find different information. And kind of a basic example to do this would be use a library like Beautiful Soup. So I'm going to go ahead and initialize that and also send a request to the website, get that source information. And this is essentially just going to be the HTML, right? And what I also want to do is use a tokenizer count so we can see what the cost implications for this is going to be. So we're going to do a token count on this raw request that we're going to make to the website. And so let me go ahead and run this. And of course, this is the HTML that we would get from the website. So if I go over here and I was to just inspect this element, then we would also get the same results here, right? So this is kind of a simple way to parse a website. The thing is, we've got 41,000 tokens if we were to be using a model like GPT-4, right? And 40,000 tokens, if we were to go through that, would essentially, well, let's calculate it right now. So we'll go to pricing. OpenAI's new model just came out yesterday, but let's say we're using a top-tier model, right? So if we've got 41,000 tokens, let's bring out the calculator here. Let's do 40,000 for the whole website. Divide that by 1 million, see the cost. So we're getting 0.04, and then times that by $10 for the 10 million tokens, right? So pretty substantial, and that's just for the input tokens, right? So for the output, $40, so you could times that by 4, and you can start to see that it does matter the amount of information that we're using for LLMs when it comes to RAG and when it comes to simple prompting with our queries as well. So it can add up very quickly, right? So then we could start doing things such as, doing some parsing on the data. So instead of dating the whole website, we would do an HTML parser, but then we're left with this kind of ugly version of the website, right? It's not much to see here. We don't have much contextual information. Things aren't organized, right? And so we could kind of do a before and after the parsing, right? Kind of get somewhere, but it's not where we want to be, right? So then we could go the other route, and we could try to use one of those very good open proprietary models that I just showed maybe from OpenAI. But the thing is, with the frontier model, you get good quality, you get robustness, you have a very well-structured document. This is a PDF that we went through, and we used a frontier model to parse. But it's expensive, as I talked about, and you start to get a large model context of tokens, right? So you could be prone to hallucinations or something like that. So what we want to do is have a middle ground here, right? We want something that understands the content of our documents, but also isn't going to be super costly. And so to do that, we can use an open source project that we'll be demoing called Docling. So Docling is kind of in the middle here, where it's using vision models, so VLMs, in order to extract the details from a PDF or a website, but then also being able to host that yourself, being able to do this all privately. And it's as I said before, Linux Foundation project that allows you to go from PDF to docx to all of these formats and get that ready for AI applications. So you have context awareness on page layout. Let's say that you have a paragraph here relating to a paragraph on the next page. Be able to truncate that into one when you do the chunking. And there's integrations for LangChain and Llama Index and whatever framework that you might be using today. So I'll kind of talk about how it works behind the scenes, but let's go ahead and see an example of it. So I want to do that same experimentation, but now we're going to use Docling. So Docling is a CLI. It's also a library, and it can also be used as a service that we'll take a look at here in a second. And what we're going to do is initialize this converter. And I have all the source code here that I'll show you just in a little bit if you want to see the repository. But what we'll do is we're going to point to that same website again. and we're going to store it as a document format. So this allows us to store all of its metadata, all of the different hierarchy of, say, tables and headings and all of that important information from our document. And then we're going to go ahead and export that to Markdown and print that out here. So let me do that again. And here we can see the same website now has been, in just 0.4 seconds on a CPU, been translated to Markdown to where I could take this and start using it in some type of RAG applications. So it's truncated, but we have the whole website there. And you could do the same thing for a PDF. Now PDF, this is where things get really interesting, because in the PDF here, I'll show you, this is the technical report for the project. But what we have here is not only text and different types of layouts, but we also have images, for example. And we also have, in addition to images, these graphs. And if I was to try to copy paste this and embed this into some type of AI application, it's not going to understand the hierarchy and the formatting of this table. So what we're going to do is we're going to also run this through Docling's document conversion. And what's happening in the background that I'll show you is that at the beginning, we could have some type of data source, and we're going to parse it firstly with OCR. So you have a variety of different models that you can use for that, and then get an idea of the layout analysis, so where tables are, where graphs are, and then the structure of tables themselves. So there's different vision models that the creators from IBM have kind of put together in order to, that have been fine-tuned in order to do this table analyzation, and then assemble that document into this Docling document format that you could use with pandas, or that you could use in order to, with Pydantic in order to represent whatever you'd like to from the document. So you could export that, create a data set, chunk that for RAG, and that's kind of how the pipeline works. So we saw that PDF there, and so after 20 seconds here for those pages, we're able to get a full kind of Markdown replication of what that PDF is. And it's really important because what we saw earlier would traditionally be pretty hard in order to convert that to an LLM format, right? So we've got, for example, this table here. If we go down to, we've got a couple tables here. But if we go down, we can see that we've got the same table here now formatted in Markdown, or we could do that in JSON, which is replicating what we have in this unstructured document, but now it's structured and ready to use with the LLM to be able to ask, hey, what is the speed on, an Apple M3 Max? And for that, it's, over a page per second, and in comparison to the other open source projects, that's pretty leading and forefront in its industry. So super cool to kind of go through websites and other types of documents, but there's a lot of formats that we're working with, right? It could be PowerPoint presentations, it could be PDFs, websites, and so what I'm going to do here is also use, in addition to Docling, 2 different libraries for manipulation of PDFs. So what we're going to have here, and I'll go ahead and install these, make sure they're good to go. What we're going to have here is a couple different file formats. So I've got, for example, and I'll open these up in my terminal, or my Finder. We've got these different files such as an annual earning report. So here we've got a lot of different data. We've got images, text, quotes. We've also got formatting for the table of contents, and also things like graphs and tables here that we want to be able to chat with, right? And so to do this locally with Docling, and as well as work with all these other types of documents, such as tables like this, what I'm going to do is kind of set up a this kind of structure here in order to, let's say, for example, import everything I need for the manipulation of these PDF files. So this is all coming from Docling itself. And set up a pipeline so that I can define the path, so where the files are coming from. So this is could be all internal. I could point to a URL. And then define with the converter the formats I want to convert, but also the format options. So I'll use a standard pipeline, but if I want to use OCR here, I could also define that. So what we're going to do is we're going to convert each of these in various types of formats. So one will be in Markdown, one will be in JSON, and one will be in YAML. So whatever type of format I need, I can go parse that. So I'll go over here, and we'll give it a second. So it's using both the visual language model and, say, for example, an OCR engine, so such as Tesseract OCR or Easy OCR. And we'll give it a second here as it's parsing these documents. But again, what's happening in the background is we're going through kind of creating a pipeline that we could automate for these different files and being able to parse them so that we can throw them into an LLM. Now, as this is happening, so I'll kind of show some examples here. I'll go over to, say, for example, the Markdown for that spreadsheet. We've got everything kind of summarized. That's kind of structured here to be able to use. And you'll notice the image tag here, and we'll get back to that in a second. You know, the idea of how do you take an image and annotate that as well is really important now that we have multimodality models. So we've kind of got these different dashboards, or not dashboards, but Markdown documents that kind of represent, just like I showed you, the different elements of this PDF. So for example, we have that big chart that we had earlier now has been extracted into this Markdown format so I could create the RAG application. Now, the next step is going from just text, right, to images. So a lot of us use Hugging Face, for example, right? Awesome. So Hugging Face has partnered with the Docling project in order to create a small VLM. So you might have heard of the small models, and this is very similar. So small VLM is a 250 million parameter model. So what I'm able to do here, and I'll go ahead and install this, is kind of configure a pipeline using this small VLM model that I could download, or I could run myself. And for its size, it does a great job. So we're going to set up a pipeline, and we're going to ask for picture descriptions, and we're going to give it a prompt for each model that was in the PDF, for example. So describe the image in 3 sentences, and also to set up the converter. So as I've been converting the PDFs, I could convert these images as well in the document. The path is going to be that PDF that we've been working with, and we're going to set up the document converter. And here, okay, size. When did that happen? Resolution max side. 1 second. Well, hold on. Let me just run that again. We'll see. All right, live demo. Live demo. Okay. Let's see. And then I just lost the other half of resolution max size. Max image size. 1 second. Let's see if we can get this working. Max size. Let me change this. 1 second. Might have had it too much. Fingers crossed. If not, it's okay. Find the output size. Max len. Default page range. I promise it didn't happen before. You know, that's tricky because I cleared the output. I was like, I want to show everybody what it looks like in action. But essentially, by using a vision model, what we're able to do is kind of take each image, place it in an array, and go through and annotate that so that we have the kind of extracted content of those images. And that's the kind of way to piece together a document so that it's not only, for example, the text and the tables, but it's also the images, for example. Hey, what's happening here? Or let's say it's submitted by customers of an insurance organization, right? We could kind of see what the detail is before someone has to manually go in and process that claim. Okay. The next part is, let's say we have all of that content from a PDF, from Markdown, and we've got that ready, and we want to embed that into an application. So the big part here is what's known as chunking. And so chunking, and I'll kind of explain this really quickly, is a way to essentially go through and process your data through a vector database and extract what's important to the relevancy of the question. So this is done using vectors and similarity scores. So it's kind of a linear algebra approach to be able to retrieve what's necessary for the user's input, right? And so there's a lot of ways to kind of go about chunking, and there's been a lot of improvements recently, but it all depends on kind of the top case, so the variety of different inputs that you can receive to the model for the response that you want to pull from the vector database. But there's also something new that's happening now that I won't really be approaching here, But traditionally, say you have the corpus of text, right? So we have those documents we've been using, and we provide that to an embedding model to a vector database. And we have some type of algorithm to pull the necessary information based on frequency of words and et cetera, et cetera. So what we're doing is going to be using the chunks, but there's also an idea of contextualizing the chunks so that you have the source information and reference information that can actually improve the accuracy of your RAG results. So this is something new that just came out pretty recently in the past year. If you're interested, Anthropic has a great write-up around it. But what I want to show you is a kind of basic approach to chunking. So what we're going to be doing is what's known as hybrid chunking. So we're going to be taking that same PDF here, and we're going to go through, do that same conversion again. But now what we're going to do is use hybrid chunking in order to specify with contextual awareness different related parts of our document in the same chunks and be able to make sure those chunks are a certain size. Because when you're chunking, you actually have to evaluate, and let me come over here to, let's see, OpenAI. Yeah, so you have to essentially evaluate how big the size of the chunk is going to be. And that can also have an impact on the price, right? So the model that you use, for example, and the performance that you're going to have on different benchmarks. So what I'm going to do here is kind of do this default hybrid chunking so that we've taken this document and parts of it that are related, for example, such as embracing our communities will then be paired with this similar information, right? And so what we could do is kind of build a RAG application to use this contextual information in a vector database. So I'm going to install some dependencies here. And what we're going to do is specify a model. So this is going to be the Mistral model, as well as an embeddings model. So this is all-in-many, which is a pretty popular model, just like Nomic is, in order to take our sentences, our text, and convert that into vectorized data. And what I'll do is I'll run this and essentially give it a prompt template to retrieve information from a vector database and answer that question. So what we'll do is also set up a temporary database. And so as I run this, we'll go ahead and just run all of these in order to load in the document. So the document is, again, going to be that report that we've been taking a look at. So now that we've got that contextualized information, what we can do is split this. And so we can split this if it already hasn't been converted. If it's been chunked, we're good to go there. And just make sure that we have these splits so our page has been broken up. Now, the ingestion into the database. So again, I have that database. It's on Milvis. And I'm going to provide our chunks, our hybrid chunking strategy to the model that we have running from that document. And then our question is going to be, what are the financials for donated food? So this is something that manually we'd have to go in and check for in the document. But what we're doing here is we're retrieving the information with a top K, so of 3. So it's going to retrieve or kind of bring in the 3 most kind of related results into the model. And we're also going to ask the question here and kind of display this back in our environment. Okay, let me see. I can't have 2 of them. Supported text generation. Okay. 1 second. I'm just going to run all of these and see what happened. In the background, what's happening is we're making a request to Hugging Face to use their models. I could do this also with Ollama, use the Ollama library. And fingers crossed. Let me clear this real quick. Okay. Huh? Yeah. It might not be a quick fix for the demos. I have one more. Don't worry. So what we're going to do is actually take all of that functionality, so defining the models that we want to use, defining the Docling loader for the document, and specifying how we want to ingest it to the database, and then setting up a RAG chain in order to ask the LLM with our prompt template and pull from the retriever, which is the database that we've set up. Fingers crossed, what we're going to do is a Streamlit run for this application. So pretty simple UI. We've just got a front end here, ask anything about the PDF, maintain chat history with the model, and fingers crossed. It might be an internet thing. I just realized that. Oh, it is an internet thing. Damn. Okay, so we'll give it a second. See what we can do. And what we're doing is running this RAG pipeline, so essentially pulling in those related chunks that we have defined from the PDF here. So this AR report that we have. Let's ask a question. So what was the donated food for 2022? Make that request to the model. Text generation. It should just be text generation. I don't have anything that would be different for it. Okay. Content. This is fun. I didn't think it would be a debugging session, but hey, maybe I'll get it working here in a second. Let me try to see. I don't want to expose my Hugging Face token, even though I have no money on there. Don't worry. We'll come back to it. We'll come back to it if we have some time. So, coming back to some of the slides. So we've kind of shown the local experience of parsing the models. RAG has been a little tricky. I think it's because we're using a third-party model and might be the internet. What's happening behind the scenes, though, as I mentioned, is that we have this kind of Docling structure of a document that we could use with pandas and make a data frame, or we could just export it to HTML or Markdown and use in a RAG application. But it's a system that's integrated into, for example, I tried to show Llama Index there, but there's also LangChain and Haystack and all of these other integrations into agentic and RAG and fine-tuning applications. So that you could take your data, prepare a data set, and have that ready to integrate into your AI applications. So again, it was demo time, and the demo kind of works. But if you want to try it yourself, I just put it up on GitHub. So I'll go back to that QR code. And maybe it'll work in the future, but I promise it worked right before. I'll go back to the QR code so you can have a look at that. Awesome. Are there any questions in the meantime? I'll try to get this demo working. I do apologize, but hopefully the session's been informative if you're looking to kind of get into data structuring and use it for your AI applications. Yeah, absolutely.
One question about the amount of resources will be required for, let's say, web scraping. Is it a huge amount of resources required for this kind of?
That's a great question. So traditionally, it's been a more GPU-intensive activity. I will point you, though, to the research paper where they did some benchmarks. So down here that you can find at docling.io, you can kind of see, let's say, if we have this M3 Mac that I have, and we have a certain amount of threads that we're using. We have like a page per second based on if I have 6 gigabytes of memory. Depends on which backend I'm using. But this is on computers without a dedicated GPU. So it depends how many pages that you're going to be going through and the number of tables, because the tables take a lot longer than just extracting like websites or just text from PDFs.
Okay, thank you. That's good to have an order of magnitude. That's what is required for this. Thank you.
Right. I'm curious, what are people working on right now for their RAG applications? Like, what are the big problems? And feel free to, yeah.
A question about tables. Did you study the different output format? Like Markdown doesn't support merge cells and stuff like that, which can leads to difficult situation. We've tried HTML table. We have some good results on it, or even LaTeX format. Sometimes it works. So I don't know if you have some experience about those different kind of output format for the tables.
Yeah, that's a great question. So what I will point you to is in the past month or so, I'll go to the documentation, they started supporting I think LaTeX and different types of like kind of research. Let me see where I can find it. But like, so let's say for example, math. So if there's equations on a table, being able to extract that. And so it's just the capabilities of the model. But the cool thing about Docling is that it's kind of plug and play. So if you have another model that you want to use that might be better, you can still use it as a backend. So let's say you're not getting the best results from a specific model or a specific library, you could integrate it. And that also brings me to a quick thing I wanted to show is that there's a serving API. So let's say that you have lots of these documents that you want to process. I could just hit this API with the kind of post request, or just use this kind of UI in order to do that. And I could specify these types of backends and what I want to use to specify like the table conversion. But yeah, hope that helps. Yeah, absolutely. Yeah, that's a great question. So it depends on the chart. It's one of the things that the team is working on, specifically these researchers at IBM, because essentially some charts could be easily processed. Right, you have x-axis, y-axis, and you could kind of put that into like a Markdown formatted table. But some are just too complex, and so that's when you would use the vision model to kind of annotate it, so that you could use, say, for example, a Llama 4 or something like that, or a better vision model. But it just depends on the complexity of the model itself. Some are supported. I don't know specifically which bar charts are. I don't want to talk too much if it's not supported, but that's probably something that a vision model would be better at, because it could kind of track that data and be able to describe it better than one of these models could. So I would say try different vision models. Llama 4 is good, and you could even plug in, say, a customized fine-tuned model. So there's documentation on how to fine-tune a model. So if you have a lot of data sets and maybe they're annotated for those graphs, you could fine-tune a vision model for that. Thank you. Yeah. Oh, shit. Sorry. Okay. Well, thank you guys so much. I'll come back to the slides.